Hi there, welcome to our next video in this integrated Math 3 video series. In this unit we're talking about polynomials and working with them algebraically. In our last lesson we looked at how to work with fractions involving polynomials and how to rewrite those with factoring techniques. In this unit we're going to look at, or in this lesson we're going to look at how to do that a little bit different way. But before we get into that, let's go ahead and do our warm-up for today. In this case, we've got 4 problems here that relate to this function up here, and then we have this separate problem here looking at division. So take a moment and see if you can do those. Okay, so in number 1 here, f of 0, if we substitute 0 in for x, every term that has an x in it is going to be 0. And so if all of these terms here are 0, the only thing we're left with is the term that doesn't have an x in it, which would be 5. So f of 0 equals 5. All right? Number 2, f of 1, this is a special property about polynomials. If we substitute 1 in for every value of x, what we're left with, because 1 to any power is still 1, what we're left with is just the sum of the coefficients. So I can do this mentally. -4 and -7 is -11, plus 6 is -5, minus 1 is -6, plus 5 is -1. So we should get -1 by doing that. So it's a quick little way to do f of 1 with any polynomial, really, is just to add up the coefficients. Write f of -x, so that's going to be -4 negative x to the 5th minus 7 negative x to the 3rd plus 6 times -x squared minus -x plus 5. So a lot of these we can actually simplify even further. This is a correct version, but we can actually rewrite this. I'm going to do that maybe down here. Is really what we can do is we can raise -1. Go ahead and raise the -1 part to all of these powers. So -1 to an odd power is still -1. -1 is going to come out of here and multiply by the -4 and make it a +4. So it's going to be +4 x to the 5th. Same thing here, -1 to an odd power is still -1. When it comes out, multiplying by the -7 makes it a +7x cubed. But here we have -1 to an even power. -1 to an even power is just 1. And so 1 times 6 just stays as 6. So it's going to be plus 6 x squared. 2 negatives make a positive x here plus 5. So this would also be a version of f of -x. Remember from earlier this year we talked about f of -x being a reflection across the y-axis. All the x values are changing. Positive become negative, negative become positive, and we're reflecting across the y-axis. And so this function here will be the same shape as that function there, which will be reflected across the y-axis. All right, I'm going to erase this just for space here and look at the next one. Negative f of x would be the complete negation of all of this. So it would be negative, and then we could just write the whole function in here if we wanted to. That would be one version of negative f of x. And then of course we could distribute this negative as well. So this would be one correct version, but another equivalent version would be distributing that negative. So it would be +4x to the 5th, +7x cubed, -6x, plus x minus 5. Would be negative f of x. Again, going back to earlier this year, we talked about negative f of x being the reflection across the x-axis. Because all the positive y values become negative, all the negative y values become positive, and so everything's going to reflect across the y-axis. So hopefully that's a good review of that. And then lastly, and this really gets into our lesson for today, is this division problem, 12 into 75. So let's go ahead and start here, and this may have been a while before or since you've looked at division, so let's recap maybe how to do this. See, 12 goes into 75 6 times. 6 times 12 is going to be 6 times 10 is 60, plus 6 times 2 is 12, so it'll be 72. Subtract, you get 3. 12 goes into 3 0 times. We'll tack on a 0 here. And let's see, 12 goes into 30 5 times. So it'll be 6 and a half. And, oh, sorry, 12 does not go into 35 times. 12 goes into 32 times. 2 times 12 is 24. Subtract and you get 6. And then you can tack on one more 0. 12 goes into 60 5 times. Sorry about that. Okay, so we have 6.25, or I'm going to write it this way. 6 plus, we can do the 0.25, or we can write 6 plus 1 fourth, or 6 plus 3/12. So it's still 6.25, but I've written it in this way to kind of show us what we're going to do here in a little bit. Because we're going to write it this way, all day today as we move forward in this lesson. So really what this means is we've got 12 goes into 75 6 times. So that's 72 with 3 additional left over. So we could write it as 72 divided by 12 plus 3 divided by 12. And so we have 6 plus a remainder of 3 over 12. Okay, so that gets into our lesson for today, which is rewriting rational expressions using inspection and long division. So this whole idea of dividing, we're going to use that same process today in something we call long division. But before we do, I want to remind you of something we did last lesson, which is simplifying fractions. So in this case, with numbers, we can use the same idea here. 8 divided by 2 is the same thing as 4 times 2 divided by 2. If we factor the numerator and find a common factor, 2 divided by 2 is 1, leaving us with just 4. So if we can find a common factor, we can actually simplify this. So in this case, over here we have x plus 4x plus 3, which factors into x plus 3 times x plus 1 divided by x plus 1. X plus 1 is reduced. Again, that's just a factor or simplifying to 1. So we're left with x plus 3. So what happens if you can't find a common factor? Or what if it doesn't go in evenly? So 7 divided by 2. 2 does not go into 7 evenly. However, we can write this as this case. So 6 plus 1 divided by 2. Let me show you why we want to do that. With a fraction, we can actually divide both terms in the numerator by the denominator. So this is equivalent to 6 divided by 2 plus 1 divided by 2. Well, 6 divided by 2 we can actually do. And that's why we separated the 7 into 6 plus 1, is because we knew that 2 goes into 6 evenly. So 6 divided by 2 is 3 plus 1 half, or 3.25. Again, I'm going to leave it in this form so that we kind of see how that's going to relate later today. So we just rewrote the numerator so that one of the pieces was went in evenly into that number. So when we come over here to this fraction, we might think that, oh, let's factor x squared plus 8x plus 10 so that x plus 3 is a factor, and then those will reduce. The problem is, not only does x squared plus 8x plus 10 not factor, but it doesn't have a factor of x plus 3. So what we want to do is we want to think about what could we, or how could we rewrite this numerator, so that it does factor into something that has a factor of x plus 3. So let's rewrite this. X squared plus 8x, that's going to remain the same. What we can change, though, really easily is the number. So let's change the 10, and let's just rewrite that. So if 3 was a factor of whatever we're creating here, it'd be 3 plus 5, right? 3 and 5 would add to give us 8. 3 times 5 would be 15. So we need a 15 here. But we still want the constant out here to be 10. So we're going to subtract 5 on the end. So it's still x squared plus 8x plus 10. We just rewrote that 10 as 15 minus 5. I'll show you why we do that here in a second. I'm going to put parentheses around the first 3 terms here because that's what we're going to factor. All right, when we factor that, we're going to get x plus 3 times x plus 5, 7 minus 5 there. But now what we can do is we can divide this first part by x plus 3 and this second part, which is the number out here, by x plus 3. Just as we did over here, right? We divided the 6 by 2 and the 1 by 2. So when we divide, I'm going to circle this first part. When we divide this part by x plus 3, what we get is x plus 3 divided by x plus 3 is just 1, leaving us with a factor of x plus 5. When we divide, I'll do this in green, when we divide minus 5 by the same denominator, we're left with just what you have there. Minus 5 over x plus 3. So again, x plus 3 goes into this part evenly, and then we're left with the second part is just going to be that fraction there, just as we were left with over here. So if we think about dividing x plus 3 into this quadratic, we're left with x plus 5 minus 5 over x plus 3. So these are equivalent forms, just rewritten, where negative 5 is what we call the remainder, just as we called the remainder over here was 1. Negative 5 is the remainder. Notice the denominator is what we were dividing by in the beginning, just as 2 here is what we were dividing by in the beginning. That's what we call the divisor. Okay, so the remainder over the divisor is this last fraction here. Okay, so this is what we call division by inspection. So we're inspecting how could we rewrite the numerator so that we could simplify and reduce. All right, so let's try another one. It says use x squared plus 3x plus 8 divided by x plus 2. So take a minute and see if you can try and factor the numerator by rewriting it first and then factor it so that it reduces with x plus 2. So see if you can do that. Okay, so in this one, if 2 is a factor, let's see, 2 plus what is 3? 2 plus 1 is 3. So our factors are going to be x plus 1 and x plus 2. So x plus 1 and x plus 2 means that we're going to rewrite this as, let's see, x plus 1 and x plus 2 multiply to give us, the 2 and the 1 multiply to give us 2. But I still want it to be 8 out here, as it was in the beginning. So I'm going to put plus 6 to still make it be 8. Now I can factor this quadratic that I built. That's going to be x plus 2 times x plus 1 divided by x plus 2. So now the x plus 2's, when I divide this quadratic by x plus 2, I'm left with x plus 1. When I divide the 6 by x plus 2, I'm just left with 6 divided by x plus 2. So if we see that there's a way that we can rewrite the numerator pretty quickly, division by inspection might be the way to go. I'm going to show you another method here in a minute. But let me give you a quick example of when division by inspection is actually a lot easier than the method I'm going to show you. So here we have x to the 7th minus 1 divided by x to the 7th plus 4. In the numerator, it's very close to the denominator. The only difference is the number here. So I wonder, what if we were able to rewrite the numerator as x to the 7th plus 4 and x to the 7th plus 4 down here, but we got to maintain the equivalency here. So we have to still subtract a 5 here, because 4 minus 5 is still that negative 1. So these are still equivalent statements. But yet, I can group these two here so that when I divide, I'm going to divide the first group by x to the 7 plus 4, and then the second group, which is negative 5, by x to the 7 plus 4. So in blue, let's see, when I divide this part by it, I'm left with just 1, which is actually, really interesting, really cool. But when I divide minus 5 by x to the 7 plus 4, I'm left with minus 5 over x to the 7 plus 4. And that's it. So if I were to use what's called long division, which I'll show you how to do in here in a minute, if I were to do that here, it would actually take quite some time. But with division by inspection, it's really quickly done here. So that's why I wanted to show you division by inspection, because there are certain situations that we can actually rewrite really quickly. Okay? So with that, let's go ahead and move on to what we call long division, which is the main method for rewriting polynomials in rational form. So on the left here, we've kind of already done this a little bit, but just to recap what we do when we divide numbers. All right, 12 goes into 36 3 times, so we wrote that at the top there. And then we take 3 and multiply it by the 12, so 3 times 12 is 36. And then we subtract the result, so 36 minus 36 is 0. And then we bring down the next number, so bring down that next 6. 6 goes into 6 0 times, so we put that up at the top there. 0 times 12 is 0. Subtract, 6 minus 0 is 6. And then bring down the next number, so bring down the next 6. 12 goes into 66 5 times, so we put that up at the top there. 5 times 12 is 60. 66 minus 60 is 6. And then, because we've run out of numbers here, we can put the decimal in the 0. So put a 0 here. So 12 goes into 60 5 times. 5 times 12 is 60. And then we subtract, and we get 0. And so this overall process of thinking about like 12 times what is 60, and then putting that result below and then subtracting is exactly the same process we're going to do with polynomials over here on the right. So this same overall process we're going to apply to this here. Now if you remember, this is the same problem we just did a minute ago using division by inspection. Let me remind you real quick. It was here. So we did division by inspection, rewrote the 8 as 2 plus 6, and then we went from there. And this was the result, x plus 1 plus the remainder was 6 over the divisor of x plus 2. Okay? So, again, vocabulary here. X plus 2 is the divisor. X squared plus 3x plus 8 is what we call the dividend. Okay, so let's go ahead and do this using the same process here of dividing numbers, okay? So here's what we're going to do. We're going to take x plus 2, but specifically the x part of it, whatever the highest power is, and we're going to think x times what is x squared. So we're just going to take the highest power of both here. X times what gives me x squared, and that would be x. So I'm going to put that up at the top. While I'm only using the x to determine that, when I go back to multiply, like we did over here, 3 times 12 was the 36, right? Well, we're going to do the same thing. So when we multiply, we actually multiply the whole thing. So x times what is x squared, so we put that up here. Then we take that value, whatever it is, in this case x, and we multiply it by the whole divisor. So x times x is x squared. X times 2 is 2x. And then what did we do over here? We subtracted, didn't we? So we're going to subtract. The main difference is when we do polynomials like this, I want you to put parentheses around the whole part right here and subtract. Okay? So, and just do it every time. X squared minus x squared is nothing. 0, right? Then you go on to the next term here. 3x minus 2x is 1x, or just x. So again, subtract every time as you go from term to term. Okay, and then what did we do over here after we got done subtracting? We brought down the next term, right? Same thing here. We're going to bring down the 8. Okay, so let's start over. Again, I'm going to do this next process in green. Again, we're basing it on x. Every time we're basing it on the highest power of the divisor here. So x times what is x? That's just going to be 1. X times 1 is x, right? Okay, so now take that 1 and I multiply it by the whole divisor. So 1 times x is x. 1 times 2 is 2. And then again, we're going to put parentheses around the whole thing and subtract. Do not try to just mentally distribute that value. I will just go ahead and subtract and think about it every time. So x minus x is nothing. 8 minus 2 is 6. Okay? Once we end up with a degree less than that of the divisor. So the divisor, the highest power of x there is 1, right? Well, the highest power of x here is 0, right? We have essentially have an x to the 0 out here, if you want to think about it that way. So anytime you're left with a result down here that's got a degree less than the divisor, then you know how to, that's when you're going to stop. Okay? So you keep going until that happens. So when that happens, this down here is our remainder. So what we're left with here is x plus 1 from up here at the top, plus, again, we always put the remainder over the divisor. So whatever we were dividing by in the beginning. So x plus 1 plus 6 over x plus 2. All right? And again, going back to division by inspection, we got the same thing. Right? Same result, same remainder, all of that. Just a different procedure, different process. Long division is probably the most robust method for dividing polynomials. So that's the one I'm showing you today. There are other methods that you might see, you might run into. Some of them can be quicker in certain situations, but the most robust method is going to be long division, right? It works in the most situations. In fact, it works in all situations. But let's go on to another example. Here we have x plus 8 is our divisor, and then x cubed plus 12x squared plus 41x plus 72 is our dividend. So let's start with x times what is x cubed? That's going to be x squared. And we're going to take that x squared and multiply by the whole divisor right here. So this is going to be x squared times x is x cubed. X squared times 8 is 8x squared. So you really need to remind yourself of the properties of exponents, right? X times x squared is x cubed, things like that. We're going to subtract x cubed minus x cubed is nothing. 12x squared minus 8x squared is 4x squared. Bring down the next term of 41x. Let's just go ahead and check. Are we finished or not? The degree here is 2. Is that degree less than the degree here? No, right? The degree here is 1. 2 is not less than 1. So we have to keep going. X times, well, I'll just do this process in red. X times what is 4x squared? X times 4x. 4x would be 4x squared, right? 4x times x would be 4x squared. Then 4x times 8 would be 32x. Don't forget to subtract. Okay? 4x squared minus 4x squared is nothing. That should always happen. The first two should always simplify to 0. If that doesn't happen, then we didn't do something right in the first place. So that should always happen. 41x's minus 32x's would be 9x's. All right? Are we done yet? No, right? The degrees are equal now. They're both a degree of 1. So we have to keep going. And add 72 here. All right? And then we have to go one more time. So let's do that one in blue. All right, x times 9, so times what is 9x? That would be x times 9 is 9x. So 9 times x is 9x. 9 times 8 is 72. Don't forget to subtract. 9x minus 9x is 0. 72 minus 72 is also 0. And this is a special situation. There's no remainder, meaning x plus 8 goes in evenly to this cubic. What that tells us is that x plus 8 is a factor of this cubic. And if we go back to previous sessions, if x plus 8 is a factor of this cubic, that means that we can rewrite, this cubic as x plus 8 times something. We don't know what the rest is, but we know that x plus 8, in fact, if we were to write this cubic in factored form, x plus 8 would be one of the factors. Therefore, negative 8 would be one of the zeros. So one of the x-intercepts would be negative 8, comma 0. So that's just something interesting. It's a special situation when the remainder is 0. That tells us that divisor is a factor of the dividend. It's called the factor theorem. All right. So if we were to divide, we would get x squared plus 4x plus 9. So that would be our answer here, our quotient for this division problem. So that would be technically our answer. So anyways, that's how we would do the division. Similar process, only we ended up with a special result this time. All right, I want you to try one. So try writing this one. We'll write it together first, and then you can actually go through the division process. So we put the denominator as the divisor out here, and then the dividend goes underneath. One thing to keep in mind, if the dividend is ever missing a term, so let's say, for example, there was not this 11x squared, so it just went 2x cubed plus 7x plus 10. If that were the case, so you can see here, it goes from a power of 3 to a power of 1. So we skip the power of 2 term. What I recommend is, if that's the case, go ahead and put that term, just put a 0 in front of it. We call it a placeholder. So go ahead and put that placeholder in if you're ever missing terms as you go down in power. So hopefully that makes sense. Obviously that was not the case in this particular situation, but I wanted to bring that up just in case you run into something like that. Don't forget that placeholder. And the same thing in the divisor. If you're ever missing a term as you go down in power in the divisor, go ahead and put those placeholders in. It just makes things match up a lot easier as you go through the long division process. Okay, let's go ahead and begin. Hopefully, you took a second to do that. X times 2x squared is 2x cubed. 2x squared times 5 is 10x squared. Don't forget to subtract. The first two terms are reduced to 0. 11x squared minus 10x squared is just 1x squared. Bring down the next term. Okay, let's start over. X times what is x squared? That would be x. Okay, x times x is x squared. X times 5 is 5x. Don't forget to subtract. X squared minus x squared is 0. 7x minus 5x is 2x. And then bring down the next term. Okay, so x times what is 2x? That would be 2. 2 times x is 2x. 2 times 5 is 10. And we're left with the remainder of 0 because 2x minus 2x is 0. 10 minus 10 is also 0. So that means that x plus 5 is a factor of this cubic here. All right, and then the quotient, the other part of that would be this quadratic. So we could technically rewrite this cubic as the product of x plus 5 and 2x squared plus x plus 2. So that's not exactly what the problem is asking us to do here, but I just want you to know that we could rewrite that as the product of those two things. If it just asks us to divide these two, then our answer, would be, of course, this quadratic here. All right. So, last one, and then I'll give you a chance to practice a little bit here. So take a moment and see if you can do this one, and then we'll go over it together. Okay, so in this case, we do have a missing term here in the dividends. We 2x cubed minus 4x squared plus 0x plus 2. I really want to encourage you to put those placeholders in. There wasn't an x term here, so we had to put 0 in for that spot. All right, then we have 2x minus 2 as our divisor. Okay, let's go ahead and start. 2x times what is 2x cubed? That would be x squared. X squared times 2x is 2x cubed, so that confirms what we thought. And then x squared times negative 2 is negative 2x squared. Don't forget to subtract. Be very careful here. 2x cubed minus 2x cubed is nothing. Negative 4x squared minus a negative. Okay, here's a little tricky situation. You gotta be really careful. Take your time here. Minus a negative is actually a plus, right? Two negatives make a plus. So this is actually negative 4x squared plus 2 would be negative 2x squared. Go ahead and bring down the next term. So just be really careful with your negatives. That's the number one error that we see with long division is sign mistakes, with negatives especially. Okay, so let's go ahead and go on to the next step here. So 2x times what is negative 2x squared? That's going to be negative x. Let's just check that to make sure. Negative x times 2x would be negative 2x squared. Okay, so that works. All right, let's go ahead and multiply the second part here. Negative x times negative 2 is positive 2x. Don't forget to subtract. All right, negative 2x squared minus negative is a plus 2x squared. So those, again, are still going to reduce to 0. 0x minus 2x would be negative 2x. And here's why we had to put the placeholder. If you didn't put the placeholder in here, you wouldn't have like terms here. You wouldn't have like terms, so it wouldn't work out as cleanly as if you put the placeholder. All right, let's go ahead and bring down the next term of 2. And let's go, well, we gotta go one more time, right? Because right here, the degrees are equal. So we have to go one more time. So the degree down here is less than that of the divisor. Okay, so 2x times what is negative 2x? That's going to be a negative 1. Negative 1 times 2x is negative 2x. Negative 1 times negative 2 is positive 2. And because we have matching expressions here, we know that the result's going to be 0, but let's just check. Negative 2x minus a negative 2x is plus 2x, it's going to be 0. Positive 2 minus positive 2, so it'd be 2 minus 2 is 0, which means that 2x minus 2 is a factor of this cubic function. So I want to give you some time to practice with these 5 and see what you can do there. I'm going to put up the answers to each of these here in a moment. So take some time, work through these 5. We'll go over one of them and then I'll give you the answers for the rest. Okay, so hopefully you were able to kind of figure some of these out. These vary in terms of the complexity. We're going to do number 4. That's actually number 4. We're going to do number 4 first, and then we'll come back and I'll give you the answers to the rest. So number 4, let's see. We have missing terms in both the numerator and denominator. So when we write these out, x squared plus 0x minus 1. And 5x to the 4th plus 0x cubed minus 6x squared plus 0x plus 1. So I hope you remember to put in those place values, those placeholders for those missing terms. All right, so now let's start and see what we get here. X squared times what is 5x to the 4th? That's going to be 5x squared. 5x squared. 5x squared times x to the second is 5x to the fourth. 5x squared times 0x would be 0x cubed. So go ahead and multiply the numbers, and then you can go ahead and put x cubed there if you want. That way the things match up. 5x squared times negative 1 is negative 5x squared. Don't forget to subtract. Leaving us with, let's see, 0 there, 0 here, and then negative 6x squared minus a negative 5. So again, be careful. Minus a negative is going to be a plus. So then go back to and figure it out. Negative 6 plus 5 would be negative 1. So negative 1x squared is what we're left over with there. We're going to bring down the next two terms. And the reason being is because we have 3 terms in the divisor. So we're going to actually get 3 terms down here. So we're going to have 3 terms to subtract from. So go ahead and bring down the next 2 terms. And let's see what happens here. X squared times what is negative x squared? It's going to be negative 1. Negative 1 times x squared is negative x squared. Negative 1 times 0x is negative 0x or positive 0x, either way. Negative 1 times 1 is positive 1. Don't forget to subtract. And we're going to be left over with 0. Meaning this is a factor of the numerator. I just want to show you real quick though. So here's our answer, 5x squared minus 1. But I want to show you just hypothetically, if we change the problem, what the result would be. If we change the problem to be, I don't know, maybe a 5 right here. Let's do this in green just so you see the difference. So 5 right here. That's going to change this to 5. And then you do 5 minus 1 is 4. So if we made that change, this would no longer be a factor of this quartic function. And this would be the remainder. So the answer then would be 5x squared minus 1 plus 4 over the divisor, which is x squared minus 1. So that's how that would change. I just wanted to show you another example of when there's a remainder involved. So it would be plus 4, that's the remainder is 4, over x squared minus 1. Okay? So here are the answers to the rest of the problems. So x plus 3 for number 1, x squared minus x minus 2 for the second one, x squared plus 3x plus 9 for the third. We just went over the fourth one. And then the fifth one, x squared plus 7x plus 2. All right? So hopefully that gives you a good idea of how to use both inspection and long division to rewrite rational expressions involving polynomials. In our next video, we're going to talk about how to quickly get the remainder. So in that last example, we ended up with a remainder of 4. How can we get that number really quickly and find out what the difference is there between what would go into it evenly and what it actually goes into starting out. So we'll talk about the remainder next time. Hopefully you'll join us for that video as well. We'll see you then.